So here we're told that in an experiment, a group of children each repeatedly throw a dart at a target. For each child, the random variable h represents the number of times the dart hits the target in the first 10 throws. So PETA models h as a binomial distribution where n is 10 and p is 0.1. State 2 assumptions PETA needs to make to use her model. Well, there's 4 assumptions we can make for the binomial distribution. We can say that there's a constant probability of hitting the target. Make sure you include the context here, so not just constant probability, but talk about the target. Each throw that a child makes at the target is independent. So they're making sure I've got the context in there as well. We can talk about the fact that there's 2 possible outcomes or that there's a fixed number of trials, but those ones are quite generic. They're a bit of a given. We were told the fixed number of trials. It's inherent that there's only 2 possible outcomes. So these are probably the better to use. So we're then asked to use PETA's model to find the probability that h is greater than or equal to 4. Right, this should really just be something we're putting into our calculator. 1 minus h is less than or equal to 3 into the calculator, and we'll get that correct answer. We know n and p, they were given to us in the question. So 0.012795. For this next part, we're told of a new variable f, which is the number of throws before the child first hits the target. And we want to know the probability that the number of throws before we first hit the target equals 5. Well, that means the first 4 attempts we failed to hit the target, so 0.9 to the power of 4. And then on the 5th attempt, we did hit the target, multiplied by 0.1. And that gives us 0.06561. Okay, so we need to be really careful with this next part. It does say that Thomas assumes that the experiment, no child would need more than 10 throws to hit the target for the first time, and he has this probability function that he wants to use to model the distribution. All right, we're asked to find the value of A. What I'm actually going to do is think of all the possible outcomes. So the amount of throws is either 1, 2, 3, 4, all the numbers up to 10. And I'm going to use his function for each of those values. So if I substitute 1 into his function, we'll get 0.01. Substitute 2 into the function, 0.01 plus A, or plus alpha, I should say. Substitute 3 in, substitute 4 in, etc. And I can start to see all of the probability, or all of the expressions for probabilities that I'll get. Okay, not sure I actually have space to put them all in here. But I'm just going to track what would it look like. Okay, so I also want to think about what would happen if I was to sum all of these probabilities together. Well, what expression would I get if I sum them together? Because I know that they should sum to 1. Okay, so there's a 0.01 in all 10 of these terms. So I can have 10 lots of 0.01. And then I can just think about how many alphas I'm going to have. And this in itself is a sequence, but I can tell that I'm going to have 45 alpha. Okay, so that should equal 1. And just some rearranging to solve gives me the value of alpha. Alpha equals 0.02. Okay, so next we're asked to use Thomas's model, this model that we're working with, to find the probability that f equals 5. Well, I just need to substitute 5 into the model, and now that I know that alpha equals 0.02, that's going to work nicely, and it's going to give me an answer of 0.09. Alright, so we're asked to explain how PETA's and Thomas's models differ in describing the probability that a dart hits the target in the experiment. Well, firstly, Thomas's model is increasing by alpha each time. So it assumes that the probability of hitting the target increases with each throw. So as you throw a dart, the next time you are more likely to hit the target. But Petter's model assumes the probability of hitting the target remains constant. She is modeling with a binomial distribution, which means the probability should remain consistent for every single attempt to throw the dart. And that's the main difference between the two. We're thinking about the probabilities and what we know about the distribution of probabilities that has changed or seems to change.